assemblies, its version, its product information, its owner information, and what are the security policies it requires, and its strong naming, and bunch of information. And definitely I'm really want to show you um, uh, in practice so that you understand these keywords much better. So to show you that, I'm actually going to create our startup project. Again, one step back to it. I know most of you might not have a licensed version of a Visual Studio. For those who don't have a licensed version, so I recommend to get the Visual Studio Express edition, which is completely free. I can actually provide you the links to that. But again, you can also, since you're all the computer science graduates, so just go to the Google and search for Visual Studio Express. If you see 2010 Express, you will get the developer tools Express edition here. I'll just open it in the new browser window so that so this is a developer edition, so which are completely free. Of course, they comes with limited features, but no matter. So all that we're going to do in our training process, all that will be supported by the 2010 Express edition, and it comes with a separate installer for each type of application. For example, if you see Visual Studio 2010 Express for Windows phones, we don't want that. We're not going to do any of that. And if it's a Visual Web Developer, again, we're using that. You can actually only do the web-based programs, nothing else. And the Visual Basic here, you can use only to create the VB.NET programs, not the C#. And again, the bottom one, you have a C# again, which you can use to create C# programs. But again, we don't want to restrict ourselves, because during my training process, wherever possible or wherever feasible, in most of the cases, I will always compare the VB.NET code versus C#.NET code, so that you will have an idea how the VB.NET code looks like, and by chance, if you have to work with the VB.NET, then it will help you out. Okay, so we'll have so in that case, if you take only C#.NET code here, see C# 2010 Express edition here, then the programs that I write with VB.NET, you cannot open them. So again, this is not the edition that you will be looking for. Again, C++ is not what we're going to do. So what you're going to need is the last one. The Express edition with all, like this is a 2010 Express ISO images, and with this you can actually do Visual Basic 2010, C++, C#, web, phone, everything. So you can do everything with this one. So I recommend you to get this one downloaded and installed in your machine. And with that, the source samples that we're going to do in this training process, I'm going to upload that to the Windows Live link in the cloud. I will actually add all of you to gain access to that cloud interface, where you can collaborate. You can download the source code from there and explore more on the source code, or you can add your own for playing around it, for you to refer it. So you can make use of this for yourself. And of course, similarly, you can also get the database as well if you want to look at it. Like if you see C++ 28 R2 Express, there is an Express edition for a database as well. You can get that as well. Okay. And yes, I assume that you have the Express edition. And once you have it installed, what you will see, so just to show what's an assembly and what's a manifest and other things, I'm actually going to start with the welcome hello world program today. To start with, once you install it, I'll have this available as a program, all programs option, and I have the Visual Studio 2010 here. link. So once I hit this, you'll of course see the splash screen and the Visual Studio ID got open. And to create a new project, all I need to do is click here and say new project. Okay, so today we're going to start with the console applications, and yes, if you see, you have multiple options to choose on the template side. I'm not interested in any other languages, and since I have 2010 Ultimate Edition, so I see most of the templates here. For you, you may not see all these templates, but which is fine. Under C#, I'm going to pick the Windows, and I'll say console application here. So this is the type of application that we're going to be make use of it in our training program. So this doesn't have any ID. The output is always will always go to the console, okay, which is your command window. I'm just saving the default location where I see temp, and I'm just going to keep this as my first .NET program. Okay, this is my first .NET program, and of course I'm going to deselect the version control here. Otherwise, I can add this project to the version control directly. But for now, I'm not interested. And create a directory for that. That's fine. So this is, again, you can actually check this box. This box is checked by default. You can keep it so that it's going to create a separate folder for your name under ctemp to create your project, so which is nice. Okay, good. So I'm going to say okay. It's taken a little time to create the use the template and create the project for me, and by default I have this as the program output. Okay, so a couple of things to know. This is the standard program structure that you will see in C#. Of course, not only C#, any .NET programs ideally, but only these the literals of the syntaxes might change, like the using keyword you see in C#. Otherwise, in VB.NET you'll see import statement in place of this. Otherwise, ideally it's same. And the namespaces, again, in VB.NET it starts with the capital N, and here it's a small n namespace. C# and VB.NET go side by side always. VB.NET is more like an English language, wherein every sentence starts with a capital letter. That's what you'll see. Everything starts with a capital letter there, whereas in C#, everything is small case. Like the N in namespace is small, C in class is small, S in static is small, so on. VB.NET, it is just opposite to it. Okay, let's not go too deep into there. Today we're going to see the what's an assembly. Okay, to see what is an assembly, we'll see what is this project properties look like. So the core thing that I'm interested here is the output type. If you see the output type, since I have created a console application, the output type of my project is marked to console application. Okay, and there are two more available here. One is a Windows application and class library. So if I pick this class library, then my output will be a DLL file, and for these two it will be exe file. Okay, and for Windows applications it will make use of the Windows Forms library, and you will have a GUI for that, whereas for console application you won't have a GUI for that. As you see, I just have only a program.cs by default. I don't have a form, FORM. Okay, so what does excuse me, so what does this have? What I'm going to do is I'm just going to say hello world. And since it's a console application, I just have to write my console to the console, and I'll say hello world. Okay, and so that I have my window keep open, so I just want to say read, so that it's going to wait till I say something. and now I just run this program. So that's my first program. So wherein I just say hello world to my console. So as I said, my console program opens in the command line window, which is just black background and white text. Of course, you can change the background and text and other things. That's a different story. So the console application output is going to be pretty much like this. Okay, since my read, I just say enter, it's terminate the program. So that's my program. Now we'll see what are the things that are by default referred in this case. So it actually referred to a couple of assemblies, and these references are as part of the template. Nothing that is added so that this is required by this program. So all of this, if I take it off, can I still compile? No. See, the console is gone. So where is this console coming from? How do you know where is this coming from? There are multiple ways to find from where this is coming from. Okay, so this is coming from system. So because I know that this is coming from system, I am able to put it directly there. If I don't know, how can I find? So that's a comment in C#. How can I do that is just copy this, go to the Object Explorer, Object Browser, in other words, and search for the console. And you'll see a ton of things here. Within that, the first one, if you see, this is called system.console. Okay, so this indicates that you're on the right hand side, it gives you that the console is a member of system. So this is the way you can identify which is the namespace that you need in your program. So Object Browser in your IDE is one of the very important tool available to look up into your base class libraries. So this will ideally going to search into the not only the base class library but also the libraries that are referred in your program. It could be your own other program. Okay, so that way you can determine which is the namespace that you need. And one of the best practice is to keep only the namespaces that are required in your program. In the earlier case, if I see I have a couple of other things like the XML or collections.generic and other things which are not required, but keeping them as a reference will actually slow down your performance. So in this case, I can also take these references out. System.data I'm not using. Now I'm going to make these remove all of these manually. So keeping this way, two things you're going to achieve. Your program is going to be very concise, and also while you're loading the program itself, need not load all those DLLs into the memory. Okay, good. So this is my program, and I will see what is the output that I have. To see an output, what in Visual Studio, what you can do is right click on this, and there is something a small tool at the bottom says open folder in Windows Explorer. Okay, so this is the easiest way to navigate to the folder in the Windows Explorer where your code files are sitting. Okay, so once I compile, you will see two important folders here, bin and obj. These two folders are temporary folders that are created by your IDE to manage your execution of the program and debugging the program inside the IDE. So obj is the folder where the program output is going to be created temporarily before it creates the final version that you're going to work with. So ideally at the end of the compilation, you will see the files in obj and bin will be same, except the final output is actually moved to bin folder under debug folder. Of course, you can have a release mode. If you compile in release mode, then you will see a release folder under bin. In this case, since I have built this with using the debug mode here, which is by default, the folder is created. In other words, I can actually pick the release mode and compile this, and I should see a release folder. So that's the mode that you pick. Based on the mode, the respective folders will be created under bin. So that's the basics again. Again, what will be the difference between the debug and release when you choose? When you make a release item, you can actually, this is the option that you would like to choose or you need to choose when you actually create a deployable components that need to go out into the respective environment wherever you want to deploy. In this case, you want to choose not to have the debug information like PDB files, and of course if you see the VS host files, these are the files that are created by the Visual Studio, which contains the debug information as well. What it means by debug information is the output of the program will also have the reference to the line of code that each line is going to do. That information will help you to have a debug. Like for example, if I have a debug pointer here, that information actually goes into your debug file, and also the line information. Inside the debug mode, if I run the program, the IDE can actually go and stop there and help your program to freeze at that point and give you a hold to the developer to manipulate the execution at runtime. So for that facility, it takes the debug information along with the compiled one and puts inside the VS host exe file, and also it contains the manifest file. And otherwise, if you see the size of this exe versus this exe, this almost it's more than a 50% back. It's like 40% of the VS host exe file. Okay, so that's a little bit of fundamentals when you create an object. So the key thing here is the output. So this exe is an assembly. In other words, if I right click this exe and go to its properties, I can see a lot of information about this assembly with respect to the security policies that you can apply to this, and also the file description, the application, and so on. These are default assembly attributes that you can normally see. So this is actually extracted as part of the, if you know the file attributes, similarly these are the assembly attributes, and you can of course set all of them inside your project properties. Okay. If you go to the assembly information, you can actually set your assembly information at this point here. And also, if you take a look at the properties here, there is something called a file called assemblyinfo.cs under the given properties dropdown. So again, this structure is not specific to a console application. If you open any application, or it could be a Windows-based application, it could be a web application, this is a standard. Okay, so none of this will be different. Only the output is going to be different, like it's going to be exe with GUI or without GUI, so on. Otherwise, you'll see the assembly information same. So within this file, you can, of course, optionally add the assembly tag and write down the respective attributes. And there are more attributes available to you when we deal here. So if you look at the assembly attributes here, ASS, so all these are assembly attributes. So there are a lot of information that you can actually attach to the assembly, more than ones that you see in the project properties window. Okay, out of that, most importantly, these are the two things that you really need to pay attention, because this is the version information that is very, very important for any application. So that's what derives or differentiate your code that you're releasing as part of a given assembly version. So this will go as part of your assembly, right? And if you right click and see the properties, details. So this is the file version, and of course the product version as well. So you can specify the version for the given project. So that assembly information, normal build scripts that you normally build with using either MS Build or Ant build scripts, or those you can automate to manipulate this information when you do a bulk release or bulk build operations that normally happen for large scale projects. Okay, good. So that's the assembly information. This is another, in other words, we refer to as a metadata. Okay, so this metadata sits along with the assembly. So now we'll see how the MSIL looks like, the intermediate language. Okay, to see how the MSIL looks like, what we need is the .NET reflection. The .NET reflection is the process through which you actually read the information that is inside an MSIL or assembly attributes. To make that possible, Visual Studio comes with a very gifted tool called the ILDASM, which is available in 2010 under the Windows SDK tools as an ILDASM. And in other words, in the earlier versions, the tool is not actually listed inside your program's menu items. And in that case, oops, I clicked the wrong one. This is not what I wanted. In those cases, if you're not having a 2010, what you can do is go to its respective command prompt. The command prompt is here inside the tools, and that's available even in 2008. Under the tools, you have the command prompt. So if you go to the command prompt, you can actually run the respective programs directly from the command prompt. ILDASM is the exe that I'm interested. So this way I can invoke this tool. This stands for intermediate language disassembler. Okay, this will help you to read through the respective. So I just copied the path where my first output is here, and I'm opening the exe. So in my, this is the manifest that we are referring to, and this is the rest of the code that goes in. So what do I have in the manifest? So this is the same information that I see under my assembly information.cs, assembly info.cs that I'm trying to set to. Okay, so that's the information. It comes with the public key token, and also since right now it's just a console application, it doesn't have any references to other DLLs and other projects. It's relatively simple and plain. And as you see, this is completely human readable except the values that are assigned to it. So these are a binary chunk of information that are compiled to it, but of course you can still see the human readable text on the right hand side, right? And so this is what the manifest is all about. And again, this will have the if I set up a couple of security policies, all that information will come in as part of the manifest. And coming down, so we'll see the code. I can also see the code. CTOR stands for the constructor .ctor. So I don't have any constructor written here, but .NET by default creates a default constructor for my program. So what is a constructor again? So if you're not familiar with what is a constructor, then don't worry about that. We will see constructor in detail in the forthcoming sessions. And the only function that I have in my code here is the static void main. And why this is static, why it is void, what is this main, we will see all of that in the forthcoming sessions. For now, we will see what is an assembly and how it looks like. Okay, and inside this assembly, this is an intermediate language. So this is how the IL looks like. So this IL, if you see the IL and underscore the line, the respective line of the code, and this is the IL specific instructions that you see. And LDSTR is hello world, that means list the string on your display. And void, it's going to if you see the MS core lib, I haven't referred this MS-core-lib in the project. If you see, we just have a reference to system. Using systems is the only one reference we have, but MS-core-lib is not referred. As I said, this is referred implicitly, and you cannot control that, because without the MS-core-lib reference, you cannot actually write even anything, including the using keyword itself. You cannot make use of it. And what is inside the MS-core-lib? Can we see? Yes, we can see. Using the same ILDASM, because MS-core-lib is again a .NET assembly, we can easily open it and see. Okay, good. So we'll see that immediately after walking through the IL language here. This is the IL for my main method, and if you see, this is the plain English readable, human readable text, which is system.console.writeLine, which is the line of code that I have here, which is the console.writeLine in this case here. Okay. So since I passed the hello world as a parameter to this, it took this parameter outside it, and it's just making the call to the respective WriteLine method of the console.writeLine class. This is the class name, and this is the namespace, and this is the method name that you're going to call, and pass the value that is stored in this line into this part. So that's how the instructions go. We don't want to really learn how the IL look, how to write IL, but just want to know what it contains. So that's the IL, intermediate language. Okay. So in MS-core-lib, can we see the MS-core-lib? Yes, definitely we can see MS-core-lib. How do we go there? We just have to go through C, Windows, Microsoft, .NET, and framework 2.0, and here we should see MS-core-lib. Yep, this is the library that we want to see. I can simply open this, and it does have the manifest, and if you see all the DLLs that is referring to, so this is a MS-core-lib that is referring to the other DLLs, and especially if you remember the extern keyword, that's the key thing that again important here. The extern keyword in C# or in .NET refers to the DLLs external to the .NET. So these are the DLLs which are unmanaged code, in other words. So these are the DLLs specific to the operating system. Example, if you know the kernel 32 DLL, it's here, and user 32 DLL relates with the security things, and secure D32 DLL. These are all DLLs specific to the operating system. So MS-core-lib is the endpoint in the .NET. So it does have a lot of other references. We don't want to really know what each of these do, and of course what it does have is the, if you take a look at in the ILDASM, the icons are self-explanatory. So if you look at this icon, this stands for like a shield, this stands for the namespaces, and the other, these are looks like a components. So these are component references that you can see. We'll expand the system namespace. System is the root namespace, FYI. That's a very, very common, very important question in .NET. What is the root namespace? The root namespace is system. Keep in mind, that's a very, very fundamental question. So as you see, the system is the root namespace. Once I expand this, I'll see all the other assemblies inside this. So it's ton of other things, like I don't want to name each and every one. A simple one of the common thing is system.math, system.object. If you see, again, system.object itself, if you see, this is a component like icon. This indicates that this is a class. Okay, and if I expand this, I can see what a system.object contains internally, and also I can also see the code, what it is internally written to. Okay, there is one more interesting tool. This is very, very intuitive, ILDASM, but there is a much more powerful tool to do all of this in a very user-friendly way. That's from Redgate software. The name of the tool is the .NET Reflector, and if you can get that tool, you can actually do that in a more user-friendly way. Okay, good. So that's, again, right now it used to be free, but now it costs $35, but still you can have a trial version down. And that's all about the assembly and the manifest information that we can look at. And multiple versions can be deployed side by side in different folders. Of course, that's again one of the most valuable addition in .NET is you can have multiple versions of the same DLL sit side by side inside the GAC. And again, what is that GAC and how you do that, all that again we'll see in the following session.